Hello, geometry people. Happy whatever day it is that you're watching this. Today is going to be our last review lesson of this semester. And today we're going to be reviewing geometric mean. So this is not your average mean. Normally if we find a average mean, like an arithmetic mean, it's when we're adding numbers and then dividing by the number of terms that we added together to get our average or our mean. But geometric mean is different. With our similar triangles, some other review lessons that we were looking at, we have been working on setting up proportions to solve for a missing value. And that is what we use in geometric mean. We're using proportions most of the time to help us find an altitude of a right triangle, or a specific measurement of a right triangle is what we use geometric mean for. So real quick, I'm just going to use this warm up as an example, and I'm going to change the directions a little bit. I just want to focus on numbers 2 and 3 here. If you ever have directions that say just find the geometric mean of ... and you're given like two numbers, find the geometric mean of these two numbers, what you're going to do is you're going to set it up pretty similarly to this. Alright? Now, the way that our textbook showed us was the way that you would set it up is for geometric mean, use the geometric mean to solve for unknown lengths. We would set it up like this. We would have a over x equals x over b. Alright, where a and b are some numbers that are greater than 0. Alright, so we would set it up as a proportion, and when we set it up like this, you'll notice that these x's are diagonal from each other. Things that are identical to each other are going to be diagonal from each other when we're using geometric mean to find a missing value. So here, let's imagine that our directions say find the geometric mean of 2 and 8. Alright, so they didn't set the first number on top and x on the bottom, but you'll notice that the x's are diagonal from each other. So we're still going to get the same answer. If we were to flip these fractions around, then we would still be multiplying x times x and 2 times 8 when we cross multiply to find our geometric mean here. Alright, so if we want to find the geometric mean of 2 and 8, what we're going to do is we are going to, just like when we solve any proportion, we're going to cross multiply. Alright, so that gives us x times x is x squared equals 2 times 8, which is 16. You guys know how to get rid of that squared? Because we just want the x. Yeah, we're going to take the square root. Take the square root to cancel out the square root in the square here. So that's going to leave us with x equals... Now, do you guys know what the square root of 16 is? Yeah, you're right. The square root of 16 is 4. If you weren't sure of that... Oh, let me get my calculator out. If you weren't sure of that, you could have plugged it into your calculator, and your calculator would have told you the square root... Whoops, I just turned it off. The square root of 16 is 4. Alright, or we can use the upside down cake method to help us break this down as well. Remember when we did that in class, we put 16 up in a box, and we thought, okay, what's a small prime number that can go into 16? Well, 2 can go into 16 8 times. Okay, now 2 can go into 8 4 times. Remember, we're thinking of prime numbers because you can't break down prime numbers. So like 2, 3, 5, 7, 11, that sort of thing. 2 can go into 4 2 times, and 2 can go into 2 once. Alright, once you hit that number 1, that's the candle to your cake. And what you're doing is you're looking for pairs of numbers. So here I've got 2 pairs of 2's, and then nothing left over. Like that candle to my cake, that's part of my cake. I don't have any leftovers, so 2 times 2 with nothing was left over in our radical sign. 2 times 2 equals 4. So that's another way we can do that. Same thing with number 3 here. If our direction said find the geometric mean of 7 and 6, this is one way that we could set it up, making sure that the identical pieces are diagonal from each other. And when we cross multiply, we're going to get x squared equals 42. So just like last time, to get x by itself, we're going to take the square root of both sides. So we get x equals the square root of 42, and we want to see if this can break down at all. Alright, so we're going to put it up in a box. Upside down cake. What's a prime number that goes into 42? Well, this is an even number, so 2 can go into 42. 2 is prime, and it goes into 42 21 times. What's a prime number that goes into 21? Okay, 3. 3 can go into 21. How many times? 7. And what's a prime number that goes into 7? 7, because 7 is prime. Alright, so there's the candle to our cake. Do we have any pairs? No, we don't have any perfect pairs on the outside of our cake. So that means we have no numbers on the outside of our radical sign, but on the inside of our radical sign, we're going to multiply back together this 2 and this 3 and this 7, which is going to give us radical 42. Alright, so that would be our final answer here for the geometric mean. Alright, so that is geometric mean just if we're given 2 numbers and told find the geometric mean of this. But I had mentioned right triangles earlier, correct? So we also use geometric mean to find altitudes or missing lengths of right triangles. So we're going to take a look at what that means with similar triangles, how to tell how to match up these similar triangles in order to set up these proportions. Alright, so I've used our old notes so I don't have to waste time drawing these triangles out. And what we've got here in this picture is this big right triangle ABC, and then inside it we also have 2 other right triangles. We've got this small right triangle ADC and this other medium-sized right triangle BDC. Alright, so what we're going to focus on first is matching up these triangles. And the easiest way that I've found to match up, to be able to tell what's corresponding in these triangles to write a statement, is to separate them out. Alright, so what I'm going to do is first I am going to take this big right triangle and I'm just going to focus on this one, this big right triangle. I'm just going to reuse it. That's C, that's A, and that's B. I'm just reusing that big right triangle. And when I reuse it or when I redraw it out, I want to label the sides. Alright? So on my big right triangle, my hypotenuse is always across from my 90-degree angle. So that means this is my height. My short side is my shortest side. And then my long leg is right here. So there's my big kahuna right triangle. Now I'm going to separate out these other 2 triangles that are inside the big kahuna. So if I take a look at this small triangle right here, I'm just going to redraw it underneath. So this point down here was A, this point up here was at C, and then when I came straight down, it came down to D. So you'll notice letter B is not in this triangle. Now what I'm going to do is just relabel the sides. So where is my hypotenuse? Across from my 90, so AC. There's my hype. Here's my short side. And then this is my long. Alright, and then I'm going to do this one more time for that medium-sized triangle. So the medium-sized triangle is like this. We have C up at the top, and if we come straight down, we've got D, and then over to the right, we have the letter B. Alright, then label your sides. We've got our hype over here. This is our longer leg, and then this is our short leg. Alright, so if we were to write a similarity statement matching up these triangles, I'm going to go ahead and just start with my big triangle here. What would we name our big triangle? Yeah, sure, triangle ABC. And then it's similar, it is similar to these other triangles. They're all right triangles, and these sides are proportional. That's why we're able to use geometric mean. Alright, so triangle ABC. What I want to do is, let's take a look at my small triangle here. ABC, so A is in between my short side and my hypotenuse. What angle, what letter on my small triangle is in between my short and my hype? Yeah, A is in between my short and my hype. Okay, so we're going to start with triangle A. Now if I look at the letter B on my big triangle, the letter B is in between my long and my hypotenuse. Alright, so which letter is in between long and hypotenuse on my small triangle? The C. And then C on my big kahuna is in between the short and the long, and D is in between short and long on my little triangle. So you'll notice that these C's do not match up with each other, because in our big kahuna the C was the right angle, but in our little triangle the C is not the right angle, which means they do not correspond. Alright? So you're going to be careful in how you match up your letters. So we're done with our small triangle. Now if we look at our medium-sized triangle and compare it to our big kahuna, what matches with A? Remember, A is in between your short and hype. So what is in between your short and your hype here on the medium-sized? Short and hype. C is in between. So that means C is going to start our triangle name. Then B on our big kahuna is in between the long and the hype. Oh, so is this medium's triangle. It's in between the long and the hype. So B comes next. And then what matches up with C? C was that 90-degree angle, and D is our 90-degree angle on the medium sized. Alright, so there is our similarity statement matching up all the parts of our similar right triangles here. And I use this to help me find geometric mean when I'm given a picture of triangles and numbers and I have to set up how to solve. So here's examples of what that looks like. Alright, we're going to start with this example right here. What I like to do is I like to go ahead and just draw all my triangles separated and then decide which triangles I'm going to use. So if I draw my big kahuna, the big triangle, there's my big triangle, okay? I'm just focusing on the big triangle, so I'm not going to put this line in the middle there right now. And what I know about my big triangle is that this little portion right here is 4, and then this part right here is 9. So what would be the whole length of that side? Yeah, the whole length of that side would be 13. But I don't know anything about this side, and I don't know anything about this long side down here. So I'm just going to leave it at that. Then if I draw this little triangle up in the corner here, do my best, doesn't need to be perfect. Okay, since 90 degrees is here, we can get 90 degrees on the other side. And what I know about this little triangle is that this short side here is 4, and this long leg here is x. But again, I do not know this side right here. And then my medium-sized triangle what I know about this medium-sized triangle is that this short side right here is x, and then this long leg right here is 9, but I don't know anything about this bottom. Alright, now on this big kahuna triangle, I only know one piece of information, and it doesn't have an x in it, so really this piece of information isn't going to help me because that's my hypotenuse, but I don't know my hypotenuse on either of my other two triangles. So really, I don't need to use that piece of information. What I'm going to be looking at is our small triangle here and our medium-sized triangle here. So we label our sides. This 4 we said was the short side, so that was short. And then this x right here on the side is not our hypotenuse because it's not across from the 90, so this is our long leg. Alright, and then on our other triangle, the medium-sized one, this x right here ended up being our short side, and then this 9 is our long leg. Alright, so again, there's multiple ways that you can set up these proportions like what we saw last week. One way you could do it is like short over long. Oop, guys can't see that. Equals short over long. You notice how these colors match up on top of each other, and the S's are directly across from each other, the L's are directly across from each other. Or another way that you could set it up is like S you could set it up like S over S equals L over L. Multiple ways you can set this up, guys, but remember, just like when we color coordinated last week with proportions, you should never have a checkerboard. Alright, that's why I like to color code. You shouldn't have the same color diagonal from each other. Alright, so when I set up this proportion, let's say I'll just do S over L, so like 4 over X equals, that was S over L, so I need S over L on my other one. S is X over my L, which is 9. Notice how these identical values are diagonal from each other, just like when we found geometric mean. So once we have this set up, we cross multiply like normal. So we get x squared equals 36, and then we would square root both sides to get x by itself. And what's the square root of 36? But 6. So there's our answer. Alright, let's take a look at letter B here. Again, same thing. I can see here, if you don't want to go through the work of drawing out all the triangles, then just look at your triangles here and figure out, okay, what do I have the most information for? So this triangle right here I have two pieces of information because I have this x and I have this 8. Alright? So I'm going to use that. So just, I'm going to redraw this just so that I don't get confused here, because sometimes it's easy to get confused. This was my x, this was my 8. Alright, and then on this triangle right here, we also have two pieces of information. We have this 4 and this 8 right here. Okay, so if I redraw that, this was 4 and this was 8. Alright. Remember how your diagonal pieces should always, or your identical pieces should always be diagonal to each other? So our 8s, when we set this up, our 8s should be diagonal. Alright, just to be sure, I'm going to label this. This is my long, this was my short, this is my short, and this is my long. Alright, so if I do S over L equals S over L, I should have S over L with purple is this 8 over X equal to S over L in my blue is 4 over 8. Hey, what do you know? These 8s are diagonal from each other. So, in this case, when we cross multiply, this time we don't have an x squared. 4 times x is 4x, and 8 times 8 is 64. So how would we get x by itself? Divide by 4, and x is equal to 16. Alright? If we take a look at letter C right here, this time we don't have a piece of information on this altitude right here. So if I were to draw out my big triangle, the big kahuna, I don't know anything about this side over here. I know that this is an x, and I know that there's a little piece that's 4 and a piece over here that's 20, so this whole length is 24. Alright? Now this small triangle right here, the only thing I know about it is that this side is 4. So this small triangle I'm actually not going to be using because I only have one piece of information. So I don't need to use this small triangle. But I can use my medium-sized triangle because I have two pieces of information, this x and this 20. So if I draw out my medium-sized triangle, I know that this is 20 and this is x. So this time when we label our sides, this 24 here is our height, and this x is our long leg. And then on the medium-sized triangle, this x is the height, and 20 is the long leg. Alright, so when we set this up, we could have like long over height. We could get x over 24 equals long over height 20 over x. Remember, your identical pieces should always be diagonal from each other. Alright, so then we cross multiply, and we're going to get x squared equals 480. Yes? So now we've got to square root both sides. So we know that x is equal to the square root of 480, but we want to see if this can break down at all. If we put it into our calculator, the square root of 480, we're going to get a nasty decimal. So that means we've got to use the cake method to break this down. Alright, so we're going to put 480 in a box. Okay, what's a prime number that goes into 480? Pick a small, easy number. 2. 2 is prime. Goes into there 240 times. What's a prime that goes into 240? Oh, 2 can go into 240 120 times. Prime that goes into 120. Okay, there's another 2. Goes in there 60 times. Prime that goes into 60. Hey, another 2. What do you know? Goes into that 30 times. Prime that goes into 30. 30 is still even, so 2 can go into 30 15 times. What's a prime that goes into 15? 3 or 5. Okay, 3 can go into 15 5 times, just like you guys had said 5. And then 5 goes into 5 once. Right? We hit the candle to our cake, so now we're looking for those perfect pairs. I've got a pair of 2's at the beginning, got another pair of 2's, and then all my others are singles. Alright? So the way that we would put all this information together is we would have x equals 2 and 2 are multiplied together on the outside of our radical sign because they are pairs. There's one pair of 2's, there's the other pair of 2's. Then all my singles go back inside the radical. 2 times 3 times 5. So when I put this all together for my final answer, 2 times 2 is 4. And then 2 times 3 is 6. 6 times 5 is 30. And there's our answer. Alright. I am going to show you one other example that looks a little trickier, but you guys can totally do it. I'm just going to help you get it set up and then have you guys work it from there to practice, and then you can take a look at the assignment. Alright? If you had a problem like this, alright, where you're given this piece of information and you need to find x and y and z. I'm going to show you how to set this up. Alright? Like I said, I like to separate these triangles so I can see them better. So, I am going to put my big kahuna out here. And on my big kahuna, I know that this whole hypotenuse is 10 and 5, making it 15. Okay, then this bottom piece down here is y, and this over here is z. Alright. Then I have a medium-sized triangle that looks like this, where it comes across this way, and my right angle's up here. What I know about that medium-sized triangle is we've got a 10, this bottom part is y, and then this is x. And then we have a small triangle, and our small triangle is going to go, we'll put it right here. Alright, and what we know about our small triangle is that this short side is 5, this long leg is x, and then our hypotenuse is z. So again, you hear me labeling these with my words. Now I'm going to write it down so I don't forget. 15 was my height. This is my long leg. This is my short leg. Here's my height. This is my long leg. This is my short leg. Here's my long leg, short leg, and height. So, when we set these up, just take it one letter at a time. If you're wanting to solve for x, what you're going to focus on is what are the two triangles that have x's in them. Alright, not the big kahuna, it's just these two. Alright, so if I want to solve for x, I'm going to use the letter x, and I'm going to use the number that I'm given. So x and 10 is my short and my long. So if I want to solve for x, I'm going to have x over 10 equals my short over long in my other triangle. Short was 5 over my long of x. Alright, and from there you would cross multiply and solve for x just like we have before. If we wanted to solve for y, what two triangles have the letter y in it? Alright, not my little one, but this purple and orange one. So if I look at my orange, y is my long leg, and then my number that I'm given is 15, and that's my hypotenuse. So if I set up like y over 15, long over hype, remember your identical pieces should always be diagonal from each other. So my long over hype is 10 over y. See how these y's are diagonal from each other? Your identical pieces are always diagonal. Alright? And then that you would cross multiply and solve for y. Then for your z, what two triangles have the letter z in them but your big kahuna and your little one? Alright? So in my big kahuna, z is my short side and my hypotenuse is 15. So maybe this time, just want to show you, you can set it up multiple ways. Maybe this time I set it up as 15 over z. So this time my letter is on the bottom. That's okay as long as my identical pieces are diagonal. So this was hype over short. Here, hype is z over my short of 5. Alright, and then I would cross multiply and solve for z. I've helped you get it set up. Now you guys do the work, and I will see you next time. Let me know if you have any questions.